Hey, how's it going, Math 1? This is Mr. Hernandez, and I want to go over this activity we did in Desmos. It is a time to take notes during this video. However, that will be in the end. And so for now, you don't have to take notes. Just go ahead and kind of look at what I'm going to be doing, and in terms of what your responses were in Desmos. So the first thing that I wanted to make clear was that there was one person in the beginning, and that one person did 3 good deeds. So now there's 3 people that are being involved here, and then each of these 3 people does 3 more deeds, and so on. And so that's basically the pattern here. So it multiplies by 3, and so we start with, again, 1. In this row, there's 3. In this row, there's 9. If you add up all these, people. And then this row would be 27 because you're going to multiply by 3. So that's where you get these numbers here, 9, 3, 27. And then after 27, you're going to multiply by another 3. And that would be 81. Now this student wrote multiplied by 3, but I'm wondering how they got the 54, but they had the right idea. It is multiplied by 3. Okay, so this one is where you get into the equation. And so the number of good deeds is expressed as 1 times 3 times 3 at stage 2. So the question is, what does the 1 represent? What does the 3 represent? And what is the other 3? And so I wanted to look at this example here. So the 1 represents how many people there were at first, or good deeds. There was 1 good deed, right? And then the 3 represents how many more people, the next 3 people that were helped. And then the next 3 represents the following step of number of people that were helped. And so the point of that is to come up with the equation. So if you had 1 is what you start with, and then these are the stages. This is the first, second, third, fourth, 5th stages. How would you write that? And this is correct. So everybody got that one right. You're going to write it as an exponent, because 3 times 3 times 3 times 3 times 3 is the same as 3 to the 5th. And then that 1 in front is also multiplying. So that's the main idea there. So the function rule is going to be written in terms of x. So number of stages is x. So we could call this x. So if we leave this as x, notice that for every stage, the stage represents the exponent. So if I follow that pattern, notice that the 1 times 3 does not change. So I'm going to recopy that. But whatever this is, whatever the stage is, that is this exponent. So I'm going to write, instead of a certain stage, I'm just going to write x. And so that is basically this here, y equals 3 to the x. You could write that, since 1 times anything is itself, you could write it as 3 to the x. But technically, there's a 1 in front of it. And the powerful thing about that is, if you break down what this means, this is the first term, or the first person. This is the multiplier, how much each thing gets multiplied by, and that is going to be, the x is going to be like what step you're on, right? So if you're on step 1, then you're going to have an exponent of 1. Step 5 has an exponent of 5. So that x represents the step. Okay, so this is where you're going to take notes at. So you want to start with today's date. For me, it's the 22nd. And this is unit 2. And the title of these notes will be Equations of Exponential Functions. And so just like the example that we had, let's just write that down since we're writing down now. So this example was the good deeds, right? So we could write it as y equals 1 times 3 to the x. And then let's label what each of these means. So this is the first term. This is the multiplier, and this is the step. And again, the important thing is on why why this is significant is because then once you have the equation of this function, you could actually write it in Desmos if you want it. Y equals 1 times 3 to the x. Well, actually, I gotta make this. I'm gonna click this a to the b power button and then raise it to the x. So this is the exponential function that you did. But more important than that, if I click this gear symbol here and I duplicate it, turn it into a table, notice that it gives me the values, and not only when I click enter, it not only gives me the values here on this table, but look at the graph. It actually creates the points too on the graph. And I could put any number here and it'll give me the value, and it'll also give me the point on the graph. And that's something that you are only able to get, from, you have to start with the equation in order to come up with the table and a graph. And so the important thing though about this is this is the y-intercept, 0, 1, and that is kind of like your starting point. Like in this example, 0, 1 represents before anything happened, there was one kid that did one good deed, and that's basically when you create your own, this is what you're going to do. You're going to write y equals a times b raised to the x power. And you could write this as the general equation for the exponential function. And you're always going to have, two numbers you're going to think of, where this is the y-intercept, or the first term, how many people are there in the beginning. There was one person in this case. And then you got your multiplier. So you could change this from a 3, where it was helping 3 people. You could change this to a 2 to say, hey, there's 2 people that are that this person is going to do good deeds for 2 people instead of 3. So you could basically change that. And that's basically the only two things that you need. And so this is what the notes are gonna mainly be about. But yeah, if we change this, let's say there was two people that started to do good deeds, and each of them did helped five people. Let's say you could basically, come up with the numbers of how many steps it would take for them to help, so many people. And so, that this table here that I'm typing into is the powerful piece as well as the graph. Um, but again, we're just looking at the y-intercept here is always going to be, so this is the y-intercept, and that is always going to be this first number, and then whatever you multiply by, that's going to be that number here, the multiplier. And so, I mean, we could do that one more time. You don't have to write these down, but this is just to kind of get you comfortable with knowing that this is going to work every time. So again, you have this table. You could add more points, but the most important thing is the y-intercept here. Remember, with the y equals mx plus b, the line, it was about it was about the y-intercept, right? You had to plot the y-intercept and then the slope. Same thing here. You have your y-intercept here, which is this first term, and then you look at your table and you say, well, each of these is multiplying by 2, and that's your multiplier. Okay, and so that's basically it. That's why this is so important, this form here, because the first number is your y-intercept, and your second number is what the table multiplies each term by.